Every time you unlock your phone, check your email, or ask an AI a question, you're using technology that took 3 to 4 months and over 1,000 precise steps to create. Welcome to the most complex manufacturing process on Earth, semiconductor fabrication. This is the hidden world where sand becomes silicon, and silicon becomes the chips that power everything you touch. Let's start with something surprising. These chips are everywhere. Your smartphone contains over 15 billion transistors. That's billion with a B. Your car? It runs on over 3,000 individual chips. And those AI models you use, ChatGPT, Claude, Gemini, they're powered by data centers filled with millions of specialized chips, all working together. Every app you open, every photo you take with Face ID, every time your car's autopilot makes a split-second decision, it all depends on these tiny pieces of silicon. Even your smart fridge has semiconductors inside. So how small are we talking? Today's most advanced chips use 2 nanometer transistors. That's just 10 silicon atoms wide. For perspective, these transistors are 100 times smaller than a virus, 10,000 times thinner than a human hair. Apple's A17 Pro chip, the one in the iPhone 15, packs 19 billion of these transistors onto a piece of silicon smaller than your fingernail. And each one switches on and off billions of times every single second. The precision required? Imagine hitting a golf ball from New York City and landing it in a specific cup in Tokyo. That's the level of accuracy we're talking about. One speck of dust, and thousands of chips are ruined. So where does this happen? Inside $20 billion factories called fabs, short for fabrication plants. These aren't normal factories. They contain clean rooms rated ISO Class 5. That means they're 10,000 times cleaner than the air outside. Workers wear full body suits called bunny suits, not because it looks cool, but because a single skin cell could ruin a wafer worth over $100,000. The air inside is filtered and recycled 500 times per hour. Temperature is controlled to within 0.1 degrees Celsius, humidity to within 1%. Even the floors are special, anchored on deep pillars to prevent any vibration from affecting the microscopic work happening inside. These factories run 24/7. Stopping and restarting? Too expensive, too risky. At the heart of these factories sits a machine that costs $380 million. It's called an EUV lithography system. And there's only one company in the entire world that makes them, ASML in the Netherlands. EUV stands for extreme ultraviolet. The light it uses has a wavelength of just 13.5 nanometers. That's 14 times shorter than visible light. This machine fires 50,000 laser pulses every second at tiny droplets of molten tin, vaporizing them into plasma, creating the light needed to print circuits invisible to the human eye. The light is so intense, the entire process happens in a vacuum. EUV light can't even pass through air. Without this technology, your iPhone would be the size of a laptop. This is what enables Moore's law to continue, shrinking transistors year after year. Now here's where it gets really complex. Building a modern chip takes 3 to 4 months. During that time, each wafer goes through over 1,000 individual process steps. The photolithography process alone, repeated more than 50 times, once for each layer of the circuit. Think about that. Stacking 50 sheets of paper and every single dot on every sheet has to line up perfectly with nanometer precision. The process repeats. Deposit a thin film of material, pattern it with light, etch away what you don't need, clean everything, inspect for defects, and then do it all again. And here's the kicker. Artificial intelligence now monitors every single step in real time, looking for any defect that could ruin the chip. Because if there's a mistake on layer 20, you can't fix it. The entire chip is scrap. Start over. Welcome to 2025. Welcome to the 2 nanometer era. TSMC, Taiwan Semiconductor Manufacturing Company, just began mass production of 2-nanometer chips in the second half of this year. Remember, 2 nanometers equals 10 atoms wide. Right now, their yield, the percentage of chips that actually work, is 65%. They're targeting 75%. These new chips are 25 to 30% more power efficient than the previous generation. What does that mean for you? Your next iPhone in 2026, 30% better battery life. AI models like ChatGPT, Claude, and Gemini, they run on data centers with millions of these chips, and 2-nanometer chips will make AI 40% more power efficient. That's critical as these models keep getting bigger. The secret? A completely new transistor design called Gate-All-Around, or GAA. Instead of controlling electrons from one side, the gate wraps completely around the channel, giving engineers unparalleled control over electron flow. We're not just shrinking anymore, we're reinventing the fundamentals. So who is making all these chips? One company dominates, TSMC, Taiwan Semiconductor Manufacturing Company. They control 64% of the global foundry market. That means 2 out of every 3 advanced chips made worldwide come from TSMC. Apple's iPhones? TSMC. NVIDIA's AI accelerators? TSMC. AMD processors? TSMC. Even Google's custom TPU chips for artificial intelligence are designed by Google but manufactured at TSMC's fabs. And they're not stopping. Right now, TSMC is already developing 1.4-nanometer chips planned for production in 2028. The race never ends. As soon as 2-nanometer launches, work begins on the next generation. Every swipe, every search, every conversation with an AI, every autonomous decision your car makes. All of it, powered by chips that took 4 months to make in some of the most advanced factories humanity has ever built. From sand to silicon to the technology that runs our world. Thanks for watching. If you found this helpful, hit that like button and subscribe for more deep dives.